Well, thank you. So this is a first for me. So as many of you can tell, I'm height challenged, right? And usually I come to these things and one of the first things I ask is, can you see me? I'm behind one of these translucent things, right? So I know you can see me. So we're all good that way. So what I'd like to talk to you today is give you sort of an intro to RPKI. And I'm not going to tell you about what bit is at what packet and that sort of thing, but I'm going to give you sort of an intro and give you sort of a status of where we stand with ROAs. So we have a bunch of operational routing challenges, right? We have things that hit the press about sites not being seen, going to other places, and so on and so forth. And this has been talked about for a long period of time. And we've had multiple solutions on the table, and we have one that seems to be quite promising with RPKI. So we're going to then talk about ARIN's RPKI components, statistics. I'm going to announce a ROAthon that we're going to have on Wednesday morning for you who want to exercise this some. And end with IRR status, because it's yet another way of doing some security things with routing. So one of the things that we have here is internet's based on two critical resources, right? DNS and BGP. And one of the things that was interesting is in about the 2001-2002 time period, Richard Clark from the White House actually convened a group of experts to talk about these two components and what could we do to secure them. And what was interesting is that DNSSEC had been around for a while, and it needed a few tweaks yet, but it's getting close to real time. And so there was a little bit of talk about that, and it's mainly from a deployment perspective. And at that point, I worked for VeriSign, and we were well on our way of experimenting with it and putting it into production. Everyone has an opportunity to use DNSSEC today. The second part of the conversation was dealing with secure routing. And what is interesting about this is that there's two competing camps that were on that phone call. One was secure BGP, SBGP, and the other one was secure origin BGP. And both of them had times at the table to talk about what they thought was best. And you can see that there was nothing really there yet on the secure routing side, where there was sort of a sort of advanced forward action by the DNS side. So you can tell today that DNSSEC is widely deployed, and we're working on security and routing to this day. So, and both of these things, of course, are very required for critical internet resources. So let's talk about some of the operational challenges we have. So before, a long time ago, the internet was built in a day where everybody knew everybody. I remember back in 1991, being able to just see who was on which system and then be able to talk to them. I think a few of you in the room probably had that same sort of experience. That's no longer the case. Then it moved on from sort of reachability on ISPs that you trust. Hey, I'll connect to you, you connect to me, I have routes to share, that sort of thing. And then it moved into contracts. And now it moved from a sort of a small set of trustable ISPs into a worldwide group, some of which have more nefarious intentions than others. So to go along with it, technology has been incomplete at best, right? We don't have a lot of automation to filter. I've been in multiple meetings with large-scale ISPs trying to solve this problem. And this is something that's been, frankly, hard to deal with. While this is going on, we've had misconfigurations, nefarious attempts, and that sort of things that have made the press, have certainly made NANOG. And one of the things that came out of this, which I thought was very telling, is IAB statement on routing, and that is, our routing is based on rumors. Think about this. The world's significant portion of the world's GDP is now based on the internet, and it's based on rumors. That's kind of scary in some ways, but it gives you sort of a challenge to what we have to look forward to actually solve in the future. So we have a couple of case studies about this. Everyone's familiar. Who's not familiar about the Pakistan case? Okay, I think most of the people here have actually realized that. We have another one in Turkey. where we had the same sort of censorship going on there, where Turk Telecom DNS wanted to order censorship for Twitter, whereas Pakistan Telecom, it was based on YouTube, and they dealt, instead of using router, in Pakistan Telecom's example, you use DNS, in Turk Telecom's example, and people routed around using Google's DNS service as a result, and so they hijacked Google's IP addresses as a result. So both these events could have been prevented with RPKI. Both these cases are well-known sort of cases within those countries. What's interesting is that the world has sort of pivoted, and now we're starting to see more cases of things going after money. So you have Dell Secure Networks having a /24 that was hijacked, and it was intercepting communications between Bitcoin miners and data pools. And then we have another one, PJSC Boss Telecom, did the same things, but with financial IP addresses of financial institutions. So you can see that they're going after targeting after fairly significant spaces of address space, including perhaps your credit card information. So we also have other cases. Amazon's Route 53 DNS infrastructure service that dealt with myetherwallet.com. And frankly, the only way it was caught, and caught this early, is that they got their DNSSEC wrong. Otherwise, it would have been gone on for a little bit longer. And then, of course, last year, we had a case where a lot of traffic was sent to a steel plant in Pittsburgh. And that, of course, made NANOG. So you can see here that we've had multiple cases. Many of these you've heard about. And yeah, okay, so what are we going to do to solve it? So existing technologies that we have today with routes of ISP of origin are when you look at the IRR registry. Okay, I can do that. Or you can do letters of authorization, LOAs. Or you just, maybe it just looks legit. Hey, I did a WHOIS entry on this particular /24 in ARIN or RIPE or APNIC or LACNIC, et cetera. And it seemed right, so I'll go ahead and announce that /24 or larger through my ISP. Or in the case of if you're enterprise or something else, maybe you're monitoring your announcements through some third party, like BGPmon, Thousand Eyes, et cetera. So do we have an alternative? Because all these things are somewhat reactive. It's either in the early stages something that's kind of error prone because it involves humans, or in the latter stages it's all sort of reactive after the case. So enter RPKI, Resource Public Key Infrastructure. It cryptographically certifies network resources, your autonomous system numbers and IP addresses, both v4 and v6. And one of the byproducts of this is that we have a way of actually certifying route announcements through ROAs, route origin authorizations. And so that allows you to actually say, this set of IP addresses comes from this origin AS. So some of the basics, and I'm just giving this to you so you can say, okay, I heard this, and now when I look at it, I understand the words are being used, so I can go into this further. So the RPKI is actually involved with multiple components. One is the repository, and within the repository is RFC 3779 certificates, which actually lists out all your internet resources for that particular organization. Associated with that are ROAs. You will have these ROAs that are associated with all your networks that you provision within the system. And then you have CRLs in the case that something went wrong, or you want to stop that ROA prematurely before its expiration date. It issues a CRL in that case. And the last part of it is a manifest. And the manifest is put in there so that you know that if you pull this information down from one of the repositories, that you're getting the entire contents, nothing more and nothing less. This is how it kind of works. So everybody has all these trust anchors on their browsers, right? Everybody goes to websites and you have all these certificates on it. And so on and so forth. And one of the things that people try to do in the very early stages is say, instead of 1,000 trust anchors like you have in your browser, we want to have one or just a handful. And you can see here that we have a hierarchy of resource certificates here that goes from IANA down to the regional registries, ARIN being one, to a regional ISP, to another regional ISP, to some end site someplace. And you can see that's how it was originally intended to work. And basically what you can do there is you can follow a path through validation on these particular route authorizations going from the trust anchor, going down. You can actually validate that that ROA is in fact correct and being signed over by the ISP who got that certificate that listed that resource. So one of the things that happened to it is that politics kind of got in the way, and there were some other operational concerns as well. And so we ended up having 5 trust anchors, one for each of the regional registries. And underneath the regional registry, again, you can issue ROAs and so on and so forth. So, and that's been working very well. So basically, in theory, what you do is you pull down these files through a repository and use a validating mechanism to make sure that you got the entire contents of all the ROAs across the internet. And then you can then communicate with your router whether or not these routes are valid. Hey, the ROA matches the route I received and everything's cool. Invalid, the ROA doesn't match the route that I received. Or unknown, basically it's insecure at that point. And then it's up to each ISP to figure out what they want to do and what local policy, what they want to do with this information. So it's fairly simple. So what does it protect? It protects unauthorized origin attacks. What it does not stop is AS padding or man-in-the-middle route attacks, both of which occurred. But it's envisioned to be a bootstrap into a stronger sort of mechanism. The first attempt on this that I mentioned very early in the day was secure BGP. It failed. And the reason why it failed is it was too complex. ISPs didn't like it. They didn't like the idea that they would have to sign hop by hop. They didn't like to have the idea that they would have to have private keys on routers in places that they may not have complete physical access to the routers, etc. The second attempt is underway, and it's a variant of secure origin BGP, which I find fairly ironic because this is something that was talked about 20 years ago, and it's called ASPA today. So it's something for you to look at if you want to follow the ITF. ASPA looks like it may be a way forward to actually deal with path validation. So we have origin validation, and we're working on path validation. So steps on using RPKI. So provision your networks, tying to your networks to your origin AS. The second step is fetch and configure a validator, and there's plenty of them, and I'll get into that in a little bit. You look at the results, and you can configure these, your validator to feed the results to the edge routers, and then filter them as you wish. So a fairly simple set of tasks to actually put into place. So let's go ahead and look at ARIN's repository, provisioning and then using. So one of the first things you need to do is whether or not you want ARIN to host your certificate of authority or you want ARIN to delegate it. And we'll go into the pros and cons in that in a minute. So the first thing you have to do in either case is sign into ARIN Online. Who here has internet resources that does not have an ARIN account? Rudiker. You have ARIN resources? I thought you're in the right region. Okay, all right. So anyways, I should probably say have resources within the ARIN region that do not have an ARIN account. If not, time to go ahead and get your account today. Once you've done so, you can actually start the process of creating your resource certificates and your ROAs. So we have 2 ways of doing it. One is hosted, where we actually do all the heavy lifting for you, and it's available via the web interface or a RESTful interface. Or you can use delegated using the up-down protocol, which is IETF standard. It's a whole lot more work, although it's starting to get easier, and this may make sense for very large networks, and I know a couple are debating the use of this today. So the pros are using hosted. It's easier to use web interface, so if you want to start just playing with this, you can go ahead and do so. It's ARIN managed, so you don't have to worry about buying HSMs, you don't have to worry about signing these things over on a daily basis, etc. The cons is right now you can't have downstream customers use RPKI. We could set it in place. We just haven't had any requests to make that happen yet. Large networks probably want to use the RESTful interface because it's sort of tedious putting in routes for each of your networks in there as well. And the other con for security people is that we hold your private key because we do these daily signings of the things that go into the repository. Delegated allows you to keep your own private key for your certificate. It follows out IETF up-down protocol and allows downstream customers of yours to actually use RPKI. The cons is to date it's been fairly hard to set up. There's new software on the horizon that's making this less daunting. Although to this day, we're having customers that are talking to us and we're actually sending snippets of ASN1 back and forth to show how things can actually work. And actually, ASN1 is very complex. It's a pain. That it's a very sort of tedious process to get it going. But there is software coming along that's actually going to make it easier, that's available on the net that people can use. You have to run your own RPKI environment, and it requires some time and effort to make it happen. And the big part of that is running your repository. So you have to go ahead when you set up these things and say, hey, this is really cool, but you have to have a highly available repository so people can actually, across the internet, can fetch your ROAs that you've created, and they can actually put it in, they can actually concentrate all these things together and actually help validate them. So you have to set up all the ROA creation, you need to set up a certificate authority, has to be a highly available repository, as I mentioned, and you need to create a certificate practices statement, CPS. So after you've gone ahead and you start saying, okay, I figured out my provisioning, I'm gonna go with ARIN hosted or whatever. What I'm going to do then is I'm going to start saying, okay, I want to start playing the RPKI ecosystem and see what's going on there. So the first thing is, and there's some multiple validators, so I'm using RIPES as an example. RIPE NCC has a nice validator that's pretty intuitive that you can pull down, and you can actually start putting all the repositories in there, and you can see what's valid and what's not valid on the internet. Within ARIN's region, you have to get the TAL, and put it into the validator. Right now, it's a very simple step. And once you're there, you can visually validate all the routes. Once you've done that, once you've got the validator in, you say, hey, this is really cool. I want to sort of plug this into my network. You can actually use this validator to talk directly to various routers using the RTR protocol. And there are various vendors, Junos, Cisco, Nokia, et cetera, that actually have this built into their software today. Their software solutions, Bird, OpenBGPD, et cetera, that also have this built into it today. So there's definitely a whole venue of different solutions you can use here. And once you set that up, you're part of the ecosystem. So here's a bunch of other validators. RIPE's not the only one. Dragon Research has one. NLNet Labs, ROUTinator has one. There's OpenBSD, RPKI client, and there's also GoRTR. There's Ripster, Fort Project, and RPKI validated through Cloudflare. So all these things are available today for you to use. So let's go ahead and start looking at the statistics. So one of the interesting things here is you can see, we started this back in 2012, and you can see that there's just a few number of participants. And over the last couple of years, over the last year and a half, it's really started to grow in terms of number of rows created and number of covered resources, and of course the number of orgs that are actually participating in this. The interesting things here is up-down delegated. So you can see it goes 0, 0, 0, 1, 2, 1, 1, 2, 2, 2, 2, 1, 1, 1, 1, 1, 1, et cetera, right? So the two actually went into it and said, oh man, this is way too hard, I'm pulling out. So they went ahead and did so. The one that's here actually never finished the job. So there's a multi-step process. They did the first step, but they're in the delegated realm. Since I've done this, there's been a bunch of other participants, well, 3 others, that have actually come into the fold. And one of them is Cynthia Revestrom, who's actually 18 and actually started playing with the software and actually pulled it down and got it to work. So this isn't that hard, and you all can actually do this. The software is getting up to snuff. The vendor in this case is saying not quite yet, don't use it quite yet, but it's getting pretty close. And you can tell that, you can see that these things are starting to occur. So let's go ahead and look at the global routing table. And you can see here, greens, the color green is the stuff that's valid, that's in RPKI land. The stuff that's not found, of course, is not in RPKI land. And invalid are the things that are misconfigured. And yeah, we have some of those. RIPE is doing quite well. You can see there that they have almost 33% that are valid. APNIC, they're the originators of RPKI in some ways. They're the ones that sort of led the pack from the regional registries perspective. They're around 15.5%. AFRINIC, 4.15%. LACNIC, around 30%. And one of the interesting things about LACNIC here is what they do is their countries have various exchanges, and they're fairly well connected at the exchanges. And LACNIC will come into the exchange and do a ROAthon there, RPKI ROAthon, and get the whole entire country under RPKI at that ROAthon. So you can see that they've had some fairly good inroads by doing so. And here's ARIN. What do y'all think? This is y'all's region. So something for us to be challenged about, and one of the reasons why we're doing this RPKI ROAthon is maybe we can get this number a little bit higher. So takeaways. If you're not using RPKI, you're more vulnerable to route hijacking. There's plenty of documentation if you don't quite get it. And hopefully some of the words I use, like repository, rows, resource certificates, and so on, start getting into that sort of mindset that you have. And the ARIN staff is more than happy to help you out as you go through this. So, as I mentioned, we're going to have an RPKI ROAthon. It's going to be this Wednesday from 10:30 to noon in the Bayview room. The objective will be y'all creating ROAs. And the only thing that you have to have is that you need to have an ARIN online account and link to resources. Now, if you want, hey, I don't want to mess with this in production, we also have an OT&E environment that's set up to be very similar to production that you can use that won't affect production at all. And if you want to do so, we can make that happen. If you haven't created your ARIN online accounts now and you want to create ROAs, go ahead and do so tonight or early tomorrow morning before 10 a.m. And we'll go ahead and replicate the information that's in production into our OT&E environment so that you can go ahead and play on Wednesday morning. So once you have all this, read the documentation below, and you can actually set up a validator while we're doing the ROAthon, and you can actually look at your results. So the other question that comes up is, what about ARIN's IRR? So RPKI, it's all kind of confusing. Hey, what's all this stuff about different ways of securing routing? RPKI is closer to real-time route validation, whereas IRR is used to generate filters, sort of a simple way put. And one of the interesting examples that Danny McPherson, one of my friends, put together is coupling the two together for better validation of data. And over time, there's been pretty significant sort of amount of religion that goes on. Hey, this is better than that, and so on and so forth. So we wanted to open it for all. So you want to use IRR, you can use IRR. If you want to use RPKI, you can use RPKI. If you want to put IRR into RPKI, if you want to put RPKI into IRR, we'll probably do that as well. So IRR has been around for decades. It was published in 1994. It's had varying degrees of success. A good friend of mine actually said that he claimed 0/0 one in the early days of RIPE. So it's had some sort of pros and cons, and it's much better now. ARIN's IRR, we're using a very old software, is bolted to the side of ARIN's infrastructure. It's definitely showing its age. It's not as customer friendly as we want it to be. There's a bunch of suggestions that the community has asked us to put out to actually fix the IRR. And we put out a community consultation, and they've asked us to go ahead and actually make the IRR better. So right now, the IRR is in development, and we're going to put in base level service this year. We're going to have a web interface available in June 2020, and phase 2 where we'll have a RESTful interface and so on, complementing the suite will be finished in December 2020. So the themes of the new IRR is promoting the validity of IRR data. Right now, if you look at our IRR, it's kind of hit or miss. We're going to provide appropriate proxy registration services. We've introduced the idea of routing contacts within ARIN Online, so you can go ahead and if the organization doesn't want you to actually muck with their organizational information or anything else, we actually set it up that routing contacts can only deal with RPKI and IRR. We also have DNS contacts for those people who want to deal with the reverse, and they can only play with the reverse part of the tree. So we've actually set that up. We are going to integrate and validate the registration database to make it valid and cross-reference RPKI work when it's appropriate. And the final part that we're going to be working with the other regional registry is cross-authentication schemes, because many of you cross various regional registries. We're also simplifying the RPSL language. We're only doing a subset of the objects that are out there. We're going to make some RESTful services out of them, make it simple, and integrate IRR functions, basically putting a web interface on IRR as well, and collaborate with other regional registries, as I mentioned, on cross-authentication. So I think I've finished, and I have 3 minutes to spare. So any questions?
Hi, Doug Montgomery. Last time I saw you talk about this, you were going to cross-populate RPKI data into route objects. Still the plan?
That is something that's been discussed, and we hope to do, yes. But that probably won't be happening this year. Probably be happening in next year. Yes, Rüdiger.
Rüdiger for Deutsche Telekom. Mark, you would not be surprised if I point back to your, I think it was the first bullet saying all of the ARIN RPKI is publicly available. How should I read that?
So you can actually pull down a repo with no authentic, you can just pull it down. There's no access control in the repo.
Okay, so the truth of the matter is the essential information that allows to validate that we got the right data is not public.
So I think you're talking about the TAL, is that correct?
I think you are correct.
So the OT&E TAL is actually published on the website. So one does not have to follow any agreement using the OT&E TAL. So if you have any issue with that particular agreement, you can still play with ARIN Online within OT&E. So you have the opportunity to do so.
Is it me? Frederick from Amazon Web Services, but talking for myself?
Yes.
So the statistics you had between ARIN and RIPE, do you think that perhaps ARIN has something to do with that the adoption is quite low in the ARIN region? Like, for example, consider making it easier to register ROAS?
So actually, one of the things that's very nice about RIPE is you do couple your meetings together. And we do that once a year ourselves between NANOG and ARIN. And so you see that synergy that frankly, I think we could do a better job within ARIN's region to actually have that synergy to make these things happen. There's also, that is something that we're working on, trying to overhaul our RPKI sort of infrastructure. We're trying to make it more user-friendly. And it's one of the things that we're going to be doing as part of modernizing our RPKI set of services.
Yeah, so obviously I think you're right on that, but do you have any timelines or any commitments, or, because I do think that the ARIN experience in terms of handling ROAS is the worst of all their RIRs.
Okay. Maybe we can talk about this offline, because you're asking sort of a big question.
Absolutely.
Okay, thank you. All right, well, thank you very much.